Hello, welcome back. I hope you all had a lovely lunch break. So my name's Claire Andrews. I'm at the University of Stirling in Scotland, in the UK. And if everyone wouldn't mind turning their cameras off who's participating, that would be great. Thank you. So just so that my job is to keep us to time, so without further ado, I'd like to introduce Beth Ventura from the University of Lincoln, also in the UK, who's going to be our first keynote speaker of this 2023 UFAW conference. Take it away, Beth.
Hey everyone, I'm so happy to be here. Without further ado, my name is Beth Ventura, and let's get this talk started. So today I'd like to make the case that in addition to the critical animal-based work that makes up the bulk of welfare science, which is why we're here in this meeting, we need to be engaging with the stakeholders who are on the ground, who affect and are affected by the welfare of animals. So in other words, we need to be paying attention to the people, the people stakeholders. And in the research space, I believe that the social sciences can really help us do this better. So what I'd like to do today is to spotlight some of the amazing work that folks have been doing to ultimately engage and understand a wide range of stakeholders in animal welfare, both the kind of end users, as it were, but also society more broadly. And I want to highlight why this kind of work, I think, is imperative in helping realize socially sustainable change for animals. And then what I'll do is I'll kind of end with a challenge for our field. So when I say stakeholders, I'm talking about anybody who has a stake or an interest in the welfare of animals. So obviously everybody in this meeting, and so a lot of us are probably people who work with animals. Our careers are bound up in animals and in animal welfare. So we've got farmers, we've got veterinarians, we've got scientists, we've got laboratory staff, behaviorists, etc. These are people who hold deep expertise and experience with animals. We're often positioned as experts. So obviously our voices are critical because we are the ones making decisions about animal welfare. And also these are people whose lives and whose livelihoods are most directly impacted by welfare. So of course we want to make sure that we're incorporating those voices. But they, or we, are not the only stakeholders in conversations about animal welfare. Non-animal professionals, so lay people or the public in general, members of society, are also critical stakeholders in conversations about welfare for a variety of reasons. They may be consumers, they may be clients, they may be customers, but even if they're none of those, they're still kind of citizens that contribute to a consensus of how society should operate. And then finally, and most importantly, the animals themselves are, of course, stakeholders in welfare, and understanding their needs is the point of kind of the whole field of animal welfare science. But I'm not going to focus on them today because we've got everybody else at this meeting who's doing wonderful talks on this subject, even though, of course, they are the critical stakeholder. I'm going to focus, though, on the humans. So I was looking back at the program for last year's UFAW meeting, and I noticed that, excuse me, that Baz Rodenberg gave one of the keynotes. Big fan, Baz, and he was speaking to the needs to transform our food system, and in order to do that, to transform our food system, to transform it in a socially sustainable way, meaning that we need to meet welfare as well as environmental considerations, as well as a variety of other stakeholder considerations. We need to do that in partnership with all of those kind of within the food sectors, and that required us to be actively involved with all of the actors along this chain. And so for today, I want to really amplify that message because I think it's critical, and it transcends not just what we need to do with the food sector, but really I think it gets to the heart of how we as a human society interact with the natural world and all of the animals within it. So whether we are welfare scientists and whether we work in the food sector or with companion animals or laboratory animals or wild animals, I think this message still resonates. That if we as welfare scientists are to make an impact with our work, that is, if welfare science is to be realized in practice and we're to translate actual meaningful welfare improvements for the lives of animals, we must account for the needs of all involved stakeholders. And this kind of imperative is what brought me into the realm of the social sciences. I hadn't started out in that area, but I started working in it in my PhD. Social sciences, if you're kind of new to these approaches, there's a lot of ways to think about them, but ultimately I think of them as kind of a set of methodologies and approaches that are bound by the goal of understanding the human experience. So there's a variety of tools that we have at our fingertips to do this. We can use surveys, interviews, focus groups, various ethnographic approaches or case studies, or the list kind of goes on. But ultimately, whether it's a quantitative or a qualitative approach, what we're interested in doing is uncovering all of the things that make people tick, that make people do the things that they do, their values, their attitudes, their beliefs, for example, that underlie their decision-making. And we're ultimately interested in all of these things because these various psychological constructs kind of influence our behavior. And so if we're interested in changing and improving animal welfare, we're ultimately interested in understanding how we can influence people and support them in changing actions to support animal welfare more proactively. So there are a variety of frameworks that have been put forth to help us understand how all of these kind of psychological constructs fit together. A couple of them that are really prominently used are things like the COM-B model and the behavior change wheel, which ultimately kind of dictate that motivation, opportunity, and someone's capability will influence behavior. So I introduced those to you right here. Another framework that has been really heavily used in application to the animal welfare sciences is this one, the theory of planned behavior. And this basically maps out that humans are more likely to perform behaviors when they intend or plan to do them. And that intention, in turn, is influenced by several factors. First, someone's beliefs about the consequences of behavior, so their behavioral beliefs. Second, their beliefs about what others think, basically the social and professional norms or pressures to perform a particular behavior. And then third, and this is really critical, and I'm going to circle back to this in a bit, their control beliefs, basically their beliefs about whether they think they can actually do the thing. And then sitting kind of above all of that are someone's values. And these kind of stay consistent regardless of context or situation. And it's really important to take account of someone's values when we're talking about trying to influence around animal welfare or anything really. And I'm going to circle back later as to why that is. But for now, what I'd like to do is to highlight some of the work of some of my heroes, where they have worked to integrate the applied work with the kind of social aspect of this work. So I'm going to start with those who work with animals, that kind of side of the coin. In this case, in a laboratory environment. And I'm gonna pick the subject of laboratory animal welfare. This is not a space that I have worked in very much myself from a research side, although I got started with, in my university time, I worked in a laboratory environment and I was the laboratory kind of care staff for years. With mice, but I'm going to start with rats because one of the many challenges faced in the laboratory welfare world, as I'm sure many folks know here, is that of handling. Handling is a challenge for a lot of reasons. And with rats, as with basically every other species that we work with, handling during either everyday care or as a part of research protocols, this causes a lot of stress. And this negatively impacts welfare, but it also negatively impacts the humans, or it can, because it makes handling more difficult and it may cause variability in the research data. But we have a solution for handling stress in the form of rat tickling. So rat tickling was first described over 2 decades ago by Jaak Panksepp and his colleagues, and it's been researched extensively since by a host of other amazing researchers, Sylvie Cloutier, Megan LaFollette. And if you've not come across this, rat tickling, in effect, is a habituation technique that mimics the way that rats play with each other. And it's more effective and it's more efficient at a number of other rat habituation techniques in creating positive affect for the rats, as well as making handling a little bit easier. Neat. However, rat tickling, when Megan LaFollette and her colleagues were investigating this, they found that it was hardly practiced, at least in the United States and in Canada. So to understand why, Megan and her colleagues conducted a large cross-sectional survey of laboratory personnel in North America, or at least in the US and Canada. And what they found was that despite the fact that like a very high majority of the staff liked the rats, which the research team compiled under a set of questions to measure attitudes toward rats, which they called ratitudes, which I am a huge fan of. That term, we should all use those terms because it just makes our life more fun. I digress. So half of them were, even when I'm recording a talk, I still can't focus. I have to digress in some respect. Okay, focusing again. Half of the staff that they surveyed had never really heard or come across of the practice of rat tickling. And even of the ones who had, most of them never actually practiced tickling techniques in their rats, or if they were, they weren't doing it correctly. So the question is why? What's going on here? And so as Megan's team kind of dug further, they asked folks about what kind of barriers they were experiencing to implementation of rat tickling. And if we look back and kind of think through that theory of planned behavior framework, we started to see that there were a number of barriers that people were experiencing. Some of those barriers involved poor behavioral beliefs around rat tickling. So for example, thinking that tickling would negatively impact the research outcomes, or it wouldn't actually yield better data. But most of the barriers involved things around people's control beliefs. So specifically, staff were citing a lot of lack of time, lack of training, or critically, a lack of buy-in from others that they were working with. And so this is what Megan's team focused on in kind of concurrent work, this area right here, those control beliefs. And what they came up with were 2 kinds of solutions to address and work within the barriers that were cited by the people on the ground. To tackle the time barrier, Megan and her team directed attention to calibrating the dosage of rat tickling, exactly how much people needed to do in order to have a good effect. And what they found was just 15 seconds, 3 times a week per rat, which kind of blows my mind, was sufficient to achieve some of those benefits that they had been observing with longer doses and exposure to rat tickling. And then to address the training issue, the group created an online training module based on their kind of experiences working with staff throughout the country. And when they exposed staff to this training module, as well as to in-person handling training, and then surveyed them before and after going through the training, the team found that the staff who took the training, even just the online training, came away with increased knowledge about rat tickling, increased familiarity and comfort with the procedure, and increased self-efficacy. So like a belief that they could do it. And then this in turn led to increased implementation of rat tickling. And so when I actually was talking to Megan about this, about her set of work and making sure that she was comfortable with me kind of spending a lot of time talking about her work, she shared with me that now they have reason to believe that the practice of rat tickling is kind of proliferating and growing, at least in North America, which is really exciting. So that's my first takeaway, that if we think through how we can link our applied research with input from the various end users, the people who work with animals every day, I think this is going to help us improve application of our findings. Great, we're done. My talk is done. No, it's not, because welfare is not a single stakeholder issue. It's not just one group's problem. It's all of our problems. And so what I mean by that is that welfare problems are complex. We have not solved them yet because they are complex. And there's a lot of reasons why they're complex, but part of this is because that animals exist within webs of multi-stakeholder networks. Humans are messy and we're a mess. And in order to solve these issues, we need kind of coordinated action from everyone if we're going to be able to accomplish anything. So I think this highlights a need for at least part of our research efforts to also look to support communication and relationship building amongst individuals who have different roles in these networks. So take the issue of dairy cattle and lameness. We have been talking about lameness in the dairy world for decades. And despite decades of research and widespread stakeholder attention to this issue, lameness remains a huge welfare challenge on many, many farms throughout the world. And so what I'd like to do is share some work that was published last year by Dr. Erin Winans as part of her PhD research. And what she was hoping to do was to bring together a host of people who hold advisory roles on dairy farms with respect to lameness, specifically veterinarians, hoof trimmers, and nutritionists. And what she wanted to do was facilitate their meeting and relationship building so that they could form lameness advisory groups to work on their client farms. And so I'm going to take you briefly through her approach at a very 10,000 foot level. But effectively, what she pursued was an example of participatory research, where research subjects are brought in at the ground level to kind of help inform the research process. So once we recruited participants, Erin brought them into planning meetings for the project, which allowed her to present her ideas for the project, and then specifically elicited participant feedback to kind of calibrate and shape the project directions going forward. From there, she held a 4-hour workshop in person, which enabled all of the participants to kind of meet each other and establish relationships with each other. And then we held a series of facilitated discussions, helping to prepare the participants to kind of go back to their client farms to work on lameness. So we had discussions on everybody's different roles that they had with respect to lameness. We worked through a couple of case studies on lameness prevention and treatment. And then the participants were essentially assigned homework to get lameness advisory group meetings up and running on their farms. And the only goal really that they were instructed to pursue was to develop a lameness action plan for each of those respective farms. And ultimately, what the participants did was hold 10 meetings on 10 of these different farms, where they reviewed lesion data on the farms. They went and walked through the farms. They worked through problem solving with respect to the specific issues that were coming up on those farms and context of those farms. And then they did some goal setting using all of the kind of stakeholder input at those meetings to establish a path forward that met the needs of all of those kind of different agendas and backgrounds. And then the way that Erin evaluated the project was to interview the participants to understand what worked about this process for them in terms of if we could maybe facilitate a better, more effective extension strategy going forward, and maybe what didn't work. And so I'm not going to go through all of the findings today, but I will highlight some of the benefits, the themes that came out of those discussions with the participants. First, that participants really valued the actual process of this research in terms of it being in person, but also because it was participatory. So one of the hoof trimmers, for example, who participated shared that they really liked the idea and how you brought it toward us, and you really took our input, or really took our input. Fancy that, like people like when they feel like their thoughts matter. Yes. They also valued being able to actually get together and meet these other stakeholders that they hadn't previously had much chance to interact with. So a nutritionist, for example, shared that just getting vets and consultants and trimmers together, I thought that was really good and something we should do more often. I don't know if I've ever been in the same room with that many qualified people all at once. And then finally, sharing intent to change behavior, or actually sharing examples of how they had changed their behavior. So for example, that they had started data sharing with other stakeholders. So a hoof trimmer sharing that the veterinarian will email me the herd report and I'll email them the trim report. The nice thing is I really enjoyed reading their notes. Or a nutritionist sharing that I learned a lot there, and one of the hoof trimmers, H3, would definitely be somebody I would talk to in the future. He's very active, and that was great. So that's my second message, that in addition to focusing kind of on single stakeholders, which is important, we also should start thinking more about how we can attend to relationships between stakeholders and support those. So as I mentioned in the beginning of my talk, it's not just those working with animals directly that we need to pay attention to. We also need to think about the public. And so while I could go in many directions for this last case, I'm going to stick with dairy. And I'm going to take up the issue of caring for young, vulnerable animals who are entrusted to our care. In this case, let's stick with the dairy calf. And I want to talk about this because I think we are uncomfortable talking about the dairy calf and how and what we do with them. But I think we need to get comfortable because many of the practices involved with managing the dairy calf are really socially unsustainable. So for example, we're starting to accumulate a lot of work that suggests that the public tends to not be very aware about certain issues. For example, cow-calf separation, or the fact that we individually house calves on many farms throughout the world. But what we do know that once people find out about this, they kind of roundly reject this for a variety of reasons. So one thought might be, maybe we can just talk to them and explain why we do those things. To which I say, I don't think you will be very successful at that effort. So that might be an unpopular opinion, but let me just defend myself. Let me just walk you through why I think that's going to be the case. If we fall into the trap of assuming that we have all the knowledge to impart, then we come into conversations with the public with all of the power. And if we do this, we fall into a line of thinking that's been described under the information deficit model. And what this model describes is basically that when experts make recommendations, or when we defend practices, when we explain the why using science, if the public does not kind of accept and come over to our side of the thing, it's because they don't understand. The corollary of this model then assumes that if the public is concerned about something, we need to go educate them out of that concern. And the approach, therefore, has been to take up that kind of gap between public expectations and expert kind of consensus, if there is consensus, through one-way education efforts, which are designed to bring the public in line with expert views. But I want you to kind of just for a moment sit and think to the last time that you had a conversation with someone where you disagreed, and they came into the conversation with the attitude that you were wrong and they were going to tell you why you were wrong. How effective was that person in actually changing your mind? Probably not very. And if they were, I'm interested in hearing about that. I think we have a tricky kind of situation because on the one hand, I think experts' beliefs about public ignorance about certain topics in animal welfare, I think those are probably correct. Like, we can all think of examples where we've interacted with someone and they had no idea what they were talking about with respect to animal welfare. So yes, communication and our engagement with the public needs to continue to be grounded in information sharing about our field. However, I think we stand to improve the efforts of our educational efforts or our engagement efforts if we can reevaluate that kind of othering, for a couple of reasons. First, the deficit model, it doesn't work, okay, in changing people's minds. And the reason, there's a few reasons why, but critically, it's because people make decisions about animals or anything, not just based on information, but based on their background, their experience, their culture, their values about animals. And information is not going to change those values. And in fact, when we share information, if it doesn't align with someone's pre-existing kind of conceptions about something, we may not actually achieve what we're thinking we're gonna achieve. It may backfire even and push them more firmly into what they originally thought. So I'm going to share an example or two of that kind of effect in action, because we need to understand that people respond differently to information because they are different. You know, nobody is a monolith. The public is not a monolith. So as an example of this effect, and you can find many, we investigated this issue a number of years ago by exploring how touring a dairy farm impacted people's shifts in knowledge and perceptions about the welfare of cattle. And what we found was that despite the fact that people learned more about how dairy farms worked and how like different husbandry practices operated, more people came away from that visit with more negative perceptions than those who came away with improved perceptions. Okay, so we kind of splintered our population. And much of that was driven by people finding out about practices like cow-calf separation and seeing calves housed by themselves on tours. And so you might dismiss that as kind of a single finding, but this finding fits and resonates over and over when we start to look through the literature. And we followed up on this work last summer together with colleagues at the University of Calgary, including led by Anna Marika Smid. What we found again was when people toured multiple farms, this time in Alberta, Canada, we saw again an increase in their knowledge about dairy farming, but segmentation in how people shifted their perceptions as a result of those tours. And interestingly, in that case, when we surveyed people immediately after their tour, relatively few were coming away with more negative views. But when we followed up with them 2 weeks later, that kind of negative perception grew. And we're still working through why that is, and we're still working through that data. So stay tuned on that. But what we suspect is that we have some work to do. So I want to kind of wrap up by thinking through how we as a field maybe should approach conversations about welfare as a society. I think we need a paradigm shift away from deficit model mindsets, where we as experts of animal welfare are the bearers of all knowledge, to one that recognizes our place as experts within a wider network within society, where we are prepared to share information, but also to receive it, where we approach conversations as a dialogue and recognize the value that different roles and worldviews bring to identifying solutions. Because I think at the end of the day, if we fail to engage society at the start of our research efforts, we may end up wasting our time and our money and our energy on working on technical solutions that might fix a welfare issue and work in our bubble, but may ultimately be rejected by the public, as well as not being usable by kind of the end users that we really want to, adopt the solutions that we come up with. And so in summary, I think to increase our research efforts, increase the impact of our research efforts, we need to consider a couple of things. We need to consider social science, because I think that if we embrace the social sciences, it will first help us ensure more effectively that what we're doing meets the needs of those who we hope will use our findings. So those on the ground, whether they're farmers or vets or laboratory staff or pet owners. I also think that if we pay attention to how we as researchers fit within complicated social networks and support relationship building and communication between stakeholders, we're bound to be a little bit more effective in implementing change. And then finally, I think we also can try to remember that animal welfare science is a field that was born out of social concern for animals. And because of this, we exist within society and we serve society. So we must remember to include them in the conversation. So doing that, I recognize means that we may need to step outside of our comfort zones. So many of us already work multidisciplinarily, if that's a word. But I urge us to don't be afraid to get interdisciplinary or transdisciplinary as well. Take inspiration from people in the human-animal interactions field and anthrozoology, and even within welfare science. So before I close, I just want to spotlight two early career scientists who I've had a chance to get to know a little bit in the last year, who I think are doing amazing work that it should inspire those of us in this field. First is Holly Vickery. She's just about to finish her PhD at the University of Reading. And while most of her work focuses on the welfare of goat kids, and she does a lot of applied work, she's also investigating why farmers may experience barriers to implementing recommended practices around, goat kid welfare, which is amazing. Or Lindsay Archangel, whose master's thesis I had the pleasure of serving as an external examiner for earlier this year. She's just finished her master's at the University of Calgary. And Lindsay was looking at integrating perspectives of not just the calf, which is critical, but also calf handlers with respect to welfare around handling of the beef calf and processing of the beef calf. It was a beautiful piece of work, and I was just really impressed, and I think that everybody should know about these two people if they don't already know about them. So I guess ultimately my message or my request or my challenge for everybody is that you don't have to become a social scientist, nor am I recommending everyone go out and start tacking on, last minute surveys to their applied work without actually talking to people who know and who've been working in this area, but maybe make some new friends. Collaborate, reach out to psychologists, to sociologists, to anthropologists, and see what kind of clever ideas they have that can help make your science and your efforts more impactful. So with that, I express my heartfelt thanks to UFAW for inviting me to speak with you today. I also would like to recognize a host of colleagues and friends for their conversations and their inspiration throughout the years. Because a lot of these ideas are obviously not just mine; they are theirs as well. So thank you so much, and I look forward to opening a conversation.
Thank you so much, Beth. If you'd like to turn your camera on now, please. We have lots of really good questions for you.
Hello, can you hear me?
Thank you. I think you're muted still.
She's not muted.
That's okay. Perfect.
You can hear me okay?
Yes, thank you.
Perfect.
First question I'd like to ask you, if that's okay, is what's your view about how we should engage with those members of the public who prefer to remain ignorant about animal welfare issues?
How should we engage with folks who prefer to remain ignorant? Well, that's a good question, and something that I grapple with myself on a near daily basis. I think I have a few different thoughts, but my first is honestly that we may need to be content with imperfect results. And I think what I mean by that is that I think we need to realize that we're not going to reach everyone, because there are people who don't want to have that conversation, or maybe aren't ready to have that conversation. And we are only, we only have so much energy and resources in a single day. I personally would probably prefer to spend my energy and focus my energy on folks who are willing to engage and have that conversation. So I'm not necessarily saying write people off, but I also think that if we try to force engagement on people who aren't interested, I don't think we're going to have much effect. So it may just be being patient, and hopefully maybe something will spark change, but maybe not. Maybe that's for the next generation to solve, but maybe that's an easy way out of that. I've just wiggled my way out of there.
Well done for wriggling. So that brings a nice lead into the next question, which is about rat tickling, which is sort of wriggling. So the question is, how do you tackle issues of human welfare and its impact on animal welfare? So specifically, many of us want to work directly with human caregivers, but then encounter issues of workers who, in theory, care about the animals in their care, but they're faced with conditions of overwork or underpay, low staffing, and perhaps as a result of this have high levels of compassion fatigue. Yep. So how can we increase animal welfare in those settings where there's lots of emotional burden on the human caregivers?
Yeah, that's a great question. And it's something that probably a lot of the people in this meeting have experienced themselves, or certainly know people who've experienced that. That's something I've experienced, certainly, working in certain animal conditions. I think those particularly are the situations that are most imperative to direct attention and energy to improving animal welfare. There's very few examples that I can think of where improving welfare of the animal is not at least going to have a mild positive effect on the people around them. But when it comes to, like, let's say working in a laboratory where the culture of care is either not there, or it's maybe different from the personal ethics of someone working in that environment, that can be really painful and isolating and just brutal. There's no one answer to solving that issue, because I think it takes concerted cultural shifts. And for anybody that's in that situation, I am not myself someone who's an expert in navigating compassion fatigue or moral distress, but I would suggest reaching out to folks who are, because I think they'll probably have much better ideas than I do about how to support folks in those situations.
Thank you. Next question is about differences between nations. So in this example, it's between European and America's labs. In how much you think people are exposed to new breakthroughs and welfare improvements. And I might broaden that to across contexts as well. So perhaps, contrasting or comparing farm versus lab contexts, maybe. Do you think that certain cultures expose caretakers of animals to more breakthroughs about welfare improvement?
I think different cultures expose workers and care staff to different knowledge about welfare? Is that the question?
Yeah, it's about breakthroughs in new knowledge.
About breakthroughs in new knowledge. Yes, I think that's likely the case, but I think this is a big question, and it's interesting because it's something that I've lived through myself. So coming from North America and moving to the UK and seeing kind of just different types of conversations that are had around welfare breakthroughs. I haven't myself experienced a huge difference in exposure to welfare breakthroughs in terms of those the tenor of those conversations. But what I have experienced is what's considered the norm is different, and what's considered acceptable and what's considered maybe even acceptable to talk about as something that can be challenged or not. Certainly there are those differences, but I think when it comes to differences in exposure to welfare breakthroughs, I think that the biggest barriers to that are probably cross context, and that's things like having findings behind paywalls. like that exists like no matter where you are in the world. But like this is, I think, what brought me into the social science interest in the first place. Is I was getting frustrated with the fact that I was publishing things that we were finding that were really cool, and we were talking about it with other people who were also like already kind of in that inner space and going to meetings and going to conferences like this. So we were getting exposed to these breakthroughs, but ultimately it was behind a paywall. And how do we get it out to the people who need it and the people that can obviously make change in the ground? So I think paywalls are the challenge that span culture and nation contexts, which is not necessarily the question you asked, but apparently I had to sneak in a plug for open access. So there you go.
Brilliant. And I think you have about 1 minute to try and answer this kind of follow-on question. Do you see a role for NGOs as kind of intermediaries in taking things that are currently behind the paywall and putting them to scientists and the public?
Yeah, absolutely. Like I think NGOs play a substantially important role in as part of that network. You know, they occupy a really important niche that can help translate research to end users. But and hopefully also just build those bridges too between the research community and end users. But I think my hope is that the researchers and the research kind of community start jumping over that bridge themselves as well.
Thank you so much. That's a really, really important thing for us to do. So we have our next speaker up, Esther. So we're going to have Esther Wurm, who's going to speak to us about using passive infrared detectors for group and area-specific activity recording in growing pigs on farm.
Hello everyone, my name is Esther Wurm and I'm from the University of Bonn. I'm pleased to be able to attend the conference today and present my data. I am going to talk about the use of the passive infrared detectors for group and area-specific activity recording in growing pigs on farm. I would like to start with a question: why is measuring animal activity in fattening pigs a useful management tool? First of all, in pig farming, the daily assessment of animal behavior and the housing conditions is required by law and part of the farm's visual inspection. But agriculture has been undergoing structural changes for years, with the result that the number of animals per farm and per person has increased. Due to the increasing number of animals per farm and per person, the farmer can only take a snapshot of the animal behavior during the visual inspection instead of an adequate monitoring. Furthermore, the activity is influenced by several factors such as enrichment material, stocking density, illness, feeding, or barn climate. For example, the group activity decreased when the animals suffer from heat stress. In their natural environment, pigs have a biphasic diurnal pattern with two activity phases during the day. If a change can be seen here in the activity pattern, this could be an indication for restlessness in the barn. For example, one study was found that before an outbreak of tile baiting, the activity was increased 6 days before. One method of measuring animal activity are passive infrared detectors. They are a cost-effective and easy-to-use sensor technology for measuring animal activity on a pen level. The PIDs were used in the project Pigs and More, and were first tested under experimental conditions at the Research Institute of the University of Bonn. The performance of the PIDs were also tested for group activity and for activity in specific areas. In this study, good results were obtained between the PID data and the video observation, especially for the group activity and for the activity in the feeding and exploration area. But sensors should not only be tested under experimental conditions, so we ask ourselves how the performance would be on farm. And that brings me to the aim of the study, that was to evaluate the use of the PIDs for general group activity and for the activity in the feeding and exploration area in focus pens on farm. The study period was in the year 2019 from April to November. The PIDs were tested in 7 different farms with growing pigs. All farms differed in the fattening period, so we had farms with pigs in the pre-fattening, in the mid-fattening, and in the finishing period. The farms differed also in terms of the group composition, so we had groups with castrated males, with mixed groups with sows and castrated males, and group of boars. The stocking density also varied, so we had groups with 60 animals, but also with 30 or 40 animals. However, we are only focusing here on the technical aspect, so each farm were examined separate. A focus pen was selected from the farms, which was equipped with 3 PIDs that you can see here in the right picture. This is what a focus pen looked like. We had 1 PID for measuring group activity. This is here the yellow one. Then 1 PID for measuring activity in the feeding area. This is here the red one. And 1 PID for measuring the activity in the exploration area. And this is here in the green one. To validate the PID data, the activity behavior was recorded by infrared cameras, and to compare the PID outcome with the recording behaviors, an etogram was used. The etogram includes behaviors which were divided into active and inactive. For example, the behavior lying was considered as inactive, and the behaviors sitting, standing, eating, or playing were considered as active. For the visual scan sampling, single frames were used at a 10-minute interval. The animals were filmed over 3 days, so that 432 still frames per farm were used for the evaluation of the group activity. Still frames for the activity in the feeding and exploration area during the night were excluded from the assessment because there was no activity at all, so that 327 still frames were used for the evaluation of the activity in the feeding and exploration area. The PIDs also measured the activity in an interval of 1 minute. The output of the activity is in percent, so that 100% means that all animals are in motion. Here you can see the PIDs in more detail. The measurement of the PIDs depends on the temperature difference between the environment and the animal surface. Due to the modification of the PIDs, the activity is not displayed in volt, but directly converted in a percentage. That means that a voltage around 1 volt is an activity level of 0%, while a voltage of 10 volt is an activity level of 100%. And the signal light here indicates if activity is currently being measured. Now I'll start with the results and the discussion. Here's an example of an activity pattern of growing pigs with ad libitum feeding. The figure shows here the comparison of the curves of group activity measured by PID, the blue line, and video observation here, the gray line. Strong correlation could be found between the PID data and the video observation of 0.82. The animals showed here a biphasic diurnal pattern with a small activity peak here in the morning and a larger one here in the afternoon. And a clear day-night rhythm were observed, with resting phases here during the night and active phases here during the day. These results are consistent with the findings of other researchers who also found a biphasic diurnal pattern in growing pigs using PIDs. But however, this result here was not because the animals were housed one day before, so it was still a new environment. This figure here shows another activity pattern of growing pigs with restrictive feeding. Here you can see also a clear day-night rhythm, but this time the pigs show an activity pattern with 4 activity peaks, and it can be seen here that these activity peaks depends on the feeding times. Furthermore, the figure shows that the PID data overestimate the activity here, the blue line, so that these activity pattern differs in intensity, but they are the same in their progression. Other researchers were also able to measure a clear diurnal rhythm with the PIDs, who also overestimate the activity, and found that the activity behavior depends on the feeding time and thus on farm management. In addition, difference in activity were examined with regard to the group composition. Here the figure shows the comparison of the group activity measured by PID for the castrated males, here the gray line, then the mixed group, this is here the yellow line, and the group of boars, here the blue line. In the pre-fattening period, shown here are 3 farms, and for a better presentation the values were smoothed over one day. The group of boars were more active than the castrated males and the mixed group. The boars also showed no clear daily rhythm and were most active during the midday, when pigs normally here rest. One reason for the increased activity of the boars could have been general restlessness. In some studies, boars were shown more aggressive compared to castrated males and the mixed group, or the increased activity correlated with the skin lesions. Animal welfare indicators were not recorded here in this study, but this one might be an example for making sure that the animals have enough rest times and that restlessness could be a sign of behavior disorders. Yeah, that brings me to the end of the results. Here in the table, the correlations are shown between the PID data and video observation for all farms. Strong correlation could be found between the group activity and the PID data for all farms, here the red one. For the activity in the feeding area, correlations between 0.44 and 0.65 could be found. Only a small correlation for farm 4 could be found here with a correlation of 0.118. This was here the farm with the ad libitum feeding. For the exploration area, only small to medium correlations were found overall, but this is currently tested in the further study. The correlations reached high values compared to the previous study, and the low correlation for the exploration area can be explained by the fact that the pen structure was often unclear, or that the exploration area were used as a transit area, which also influenced the PID data. In summary, PIDs are suitable for measuring group activity and activity in focus areas, for example for the feeding area. Then, with the support of the PIDs, activity patterns can be recorded, and in combination with other sensor systems, the PIDs will support the farmer and animal welfare. Thank you for your attention, and I'll be pleased to answer your questions. Thank you.
Thanks so much, Esther. Are you hearing us loud and clear now?
Yeah, it's okay. It's still quiet, but I think it's works.
Great. So we have some questions coming in for you. So first up, in your data, how would you distinguish between many pigs moving a little bit and a few pigs moving a lot?
Yeah, that's the problem with the PIDs. The PIDs cannot measure the number of animals. So that's why we have in the feeding area for farm 4 with the ad libitum feeding, we had the low correlation, because at the ad libitum feeding, the animals are throughout the day at the feeding area, and the PID cannot notice this. It can be that it's 2 animals at the feeding area, or 4 or 5, and that's the limitation.
Brilliant. All methods have them. So I guess another kind of methodological question. So how can we be sure that PID overestimates activity and not that human video observations underestimate activity? And that's especially taking into account that these manual observation methods use sampling, whereas the PID method has been using continuous recording.
Yeah, that's a good question. There are many opinions. I don't know. We have the scan sampling of 10 minutes, and that's the shortest one we can use for it. Maybe the activity is underestimated due to the scan sampling, but I think in comparison of other studies, yeah, they all said that the PIDs overestimate the activity.
Thank you very much. And one more, how do you annotate activities specifically for pigs housed in groups? So do you employ humane annotation or utilize software, sorry, human annotation, or do you utilize software-based methods?
No, we used human authorization.
Thank you.
And also the growing pigs were recorded over 3 days, and then the students used the scan sampling and yeah, recorded the behavior.
Thanks so much. And if anyone has questions left over, you can take them over to the Slack channel. So onwards with our next speaker, thank you, Christina Stanley from University of Chester and Durrell Wildlife Conservation Trust, who's going to talk to us about individual welfare in group living species, the Livingstone's fruit bat as a case study.
Hi everybody, my name's Dr. Chrissy Stanley and I'm going to be talking to you today about individual welfare in group living species using the Livingstone's fruit bat as a case study. A lot of animals commonly live in quite large social groups in captivity, and monitoring their welfare is essential. One way of doing this is at the group level. This is really useful where individuals are not easily identifiable. It could be used where individuals are in quite a large social group, so this makes it more economical. Or it could just be that this species is commonly assessed as a group, that's just what's normally done. When monitoring group level welfare, interventions can only be made when an impact is noticed on the welfare of the actual group. Another way of monitoring welfare is to look at individual welfare in groups. Of course, this is only possible where individuals are identifiable, perhaps by using leg rings or microchips. And it can be used where there's a semi-automated process in place. This can make things a lot more economical, a lot easier to manage. But the benefit is we can track individual welfare over time and we can see changes happening at an earlier point. This can mean that interventions can be initiated earlier, but also that they can be targeted at certain individuals who need them. For example, subordinate individuals who are not being allowed access to food. Of course, in practice, both individual and group level welfare are intertwined and both can be assessed concurrently. In group living species, social interactions are a very important component of welfare. We often categorise these according to whether they're positive or negative. I think we could all agree that those on the right are positive social interactions. We have individuals investigating each other and grooming each other in the bottom and top pictures. And in the middle we can see these parrots appear to be choosing to associate in close proximity without showing any aggression. However, in the pictures on the left we can see more negative social interactions. We can see fighting behaviour and dominance behaviour here. But of course, individual social experiences vary within a group. Individuals do not have the same frequency and duration of negative and positive interactions. Different individuals will have different experiences of these over time. And social network analysis can be a really good way of quantifying these social experiences of individuals. So for example, if we look at this quite simple network here in long-tailed macaques, this is an allo-grooming network, so it shows how frequently individuals groom each other. The thicker the line, the more frequently they groom each other. You can see here that individual F1 in the top only has one strong bond and two weaker ones. It frequently grooms this individual and very infrequently has groom interactions with these other two. Whereas if we contrast that to individual F5 in the middle, this one has two quite strong grooming relationships, then it has four quite weak ones, so it's quite central within the group. The social network analysis can be really useful to quantify these social positions within a network. And this can allow us to develop an early warning system for poor welfare. We can find out where poor welfare is more likely at an earlier point. Today I'm going to show you an example of how we can apply social network analysis in combination with other techniques to look at colonies of Livingstone fruit bats. So first of all, I better tell you something about Livingstone's fruit bats. They're a critically endangered species. There are only about 1,200 left worldwide. They live in the islands of Anjouan and Moheli in the Comoros Islands. So this is quite close to Madagascar here on the right. And they're very susceptible to extreme weather events and deforestation. There are frequent cyclones in this region, and they could easily wipe out all the roosts for this species. So a captive breeding population was established from 17 wild individuals in 1992 by Durrell, and nowadays there are about 86 individuals currently in captivity in just 2 institutions worldwide. And this species is chronically understudied. There's a lot we need to know about it. In the bottom right here, you can see the location for most of the data collection talked about today. This is at Jersey Zoo. In order to investigate individual welfare in the Livingstone's fruit bats, I've been leading a project for a number of years. And between 2019 and 2022, I had a PhD student, Morgan Edwards, who's pictured here in the top right, who worked on this population at Jersey Zoo. So the first thing that she did was to look at all the individuals in both 2019 and 2020 to do some behavioural observations. So there were 44 individuals in 2019 and then 50 in 2020 in the main population at Jersey Zoo. And the great thing about them is you can individually ID them. First of all, they've got pit tags, so you can actually scan them, but mainly you can look from a distance and you can look at the ear notches that they may have and also the coloration of their back. You can see here that there's a particular shape on the back of this individual, and they all vary very slightly in colour as well. So Morgan completed 1,028 focal scans in total. She looked at the duration and the direction of all the behaviours recorded using the Animal Observer app, and then built social networks based on association, affiliation, and aggression. On the left, you can see one of the social networks. This is an association network where the thickness of the line between 2 individuals shows how frequently they were seen associating together in close proximity. These networks were quite complex. We found there were between 3 and 4 different types of relationships going on between individuals in these networks. We found that the association network predicted both the affiliative and aggression networks, so individuals that spent more time in close proximity also interacted more frequently, but they showed more frequent affiliative interactions than aggressive interactions. We found significant positive age and dominance-based assortment, which means that individuals of a similar age and a similar dominance rank were more likely to spend time together. And we found that these social roles, these places within the network, remained stable between the 2 data collection periods. So from this we can make various recommendations in terms of welfare. So first of all, we know that strong social bonds do exist in this species. So we need to avoid separating individuals that do have these strong bonds. So for example, if we're moving individuals between populations, it would be wise to move them with their bonded individuals. And we also recommend that we can use social network analysis to monitor changes in relationship structures so that welfare issues can be identified at an earlier point. Of course, the type of enclosure used can have an influence on individual level welfare. So we then came up with a new method for quantifying enclosure use at the individual level using principal component analysis. Commonly, this is something that's done at the group level, but we wanted to find out how individuals use the enclosure. So we split the enclosure into 42 hypothetical sections, as you can see on the left-hand side here. And then Morgan carried out behavioural observations using scan sampling to determine how many individuals and which individuals were in each section at different times of the day in 2 different data collection periods. She then used this new method to come up with an enclosure use style for each individual. On the right here you can see the same enclosure diagram, but this is coded by the different enclosure use styles. So each style has a different colour, and different individuals were allocated these different styles. So for example, if you look at the light blue rectangles, these individuals all share the same enclosure use style, and they commonly use these 3 enclosure sections. Whereas those in the dark green, again, this is a group of individuals that all share the similar style. They use multiple different sections across the enclosure. You can see the white sections are areas that were never used at all by this species during this data collection period. And then we've put various resources using the different symbols to show the resource's influence on enclosure use. For example, triangles represent the heaters and the stars represent the feeders. She then found that sex correlated with enclosure use style, and the enclosure use style was consistent across the 2 data collection periods. So from this we can make some welfare recommendations. For example, we can use this method to make sure that enclosure designs allow animals adequate spatial choice, and that maximises individual welfare. It allows them to use the enclosure to their advantage. The next stage of this project was to look at physiological correlates of welfare, in particular looking at cortisol levels and how these related to behaviour. To do this, Morgan and a collaborator collected 92 faecal samples across the 2 populations in captivity at Jersey Zoo and Bristol Zoo. And after analysis, she found out that individuals that commonly linked social groups, they had what we call high betweenness in social networks, had significantly higher cortisol levels. So these are the individuals that more commonly move between social groups, were showing higher levels of this hormone that's commonly associated with stress. Conversely, she found that individuals with high quality positive relationships, i.e. high strength in social network terminology, had significantly lower cortisol levels, showing there's a positive influence of these relationships. Finally, she found that the duration of one particular behaviour, self-directed grooming behaviour, positively correlated with cortisol concentration. So this could be indicating higher levels of stress in certain individuals. So in terms of welfare recommendations, we can recommend that we try and maintain strong social relationships where possible, because this could be very important in terms of social buffering. So individuals that are in these strong relationships experience generally lower cortisol levels, which shows the strength of these relationships. And we also suggested that self-directed grooming behaviour could be used as a potential welfare indicator in this species. Finally, we developed an association with nature counters RFID technology so that we could explore foraging networks in this species. So the apparatus we designed had various components. First of all, it had this antenna region which read a signal when a bat moved through it. The bats all had their own transponders already because they are all fitted with microchips, pit tags, as they're commonly used in many zoo and other domestic animals. And then finally there was a reader and a logger on the side which stores which individual has passed through the transponder. We then added a few additional aspects to these. So we added a feeder at the bottom that the bats would choose to access to get their daily feed, a strain gauge so that we could assess the individual's mass, and side panels to stop the bats from entering the feeder from different sides. And these devices won the Silver Biasa 2021 Award for Welfare and Behaviour. We validated this technology by using camera trap footage, which shows it was 85% effective. The only time it wasn't reading individuals' presence was when they had perhaps older microchips. We then installed 8 of these readers in the enclosure for a 3-month period and downloaded the data 2 to 3 times per week. We used that data to build foraging networks, so we decided that if individuals visited a feeder within 3 minutes, they were defined as being associated. And then we used cluster analysis, mixed effects and hurdle models to understand predictors of centrality in this species in the foraging networks. What did we find? Well, we found that age and sex did predict foraging strategy. We found that individuals that were older were more highly connected with the rest of the group. They had high betweenness, but they foraged near only a few individuals. They had very low strength, and that's summarised in this diagram A on the left. And then for younger individuals in diagram B on the right, they foraged more frequently in a larger group, so they had higher strength, and they foraged with individuals of the similar age. They showed age-based assortment, and they rarely deviated from these groups, so they had low betweenness. They weren't as well connected to the rest of the group. So from this we can make some welfare recommendations. For example, we can recommend that these groups are fed in multiple different locations, and this is because in the wild we know that males will defend feeding territories from subordinate individuals, and so we need to have lots of different feeding locations so that these younger individuals are able to access enough food. So to summarise, these studies combined together with these different methodologies have been used to identify various risk factors in this population, to then suggest which interventions can be made at early stages, and these all combine to result in positive individual level welfare. And this is a good example of evidence-based management of captive groups. So I hope I've shown you how social network analysis can be useful for evidence-based management in captive groups. We can use this to maximise the welfare of a population by looking at social experiences at the individual level. But to make this easier to implement in reality, we need to find better technology so that we can automatically collect data at the individual level and make this more economical. We also need to create more user-friendly code and software so that those who are responsible for welfare can more easily implement these methods. Special thanks go to Morgan Edwards, my PhD student who collected and analysed most of this data, and Professor Tessa Smith, who oversaw the conservation and physiology side of this project. But thank you to all these other people who are involved in this project. And please do ask me any questions you have at the end of this presentation. And here are the references used in this presentation.
Thank you so much, Christina. That's a lot of data has gone into that talk. So we have some questions for you. So you mentioned that moving socially bonded individuals may be best done with one another. So I wonder has this been something that's been tried or investigated? And do you think zoos might be amenable to this kind of approach?
I think so, yes. So a lot of the time we look at genetics to decide which individuals to move between groups because we're interested about enhancing genetic diversity. But I think it's quite easy to think about which individuals have other characteristics that we may want to think about. So, for example, these social bonds are so important. And for a critically endangered species like this, we really want them to be breeding well in captivity. And we know from a large range of species that having strong social bonds can have a significantly positive influence on reproductive success. So if we want individuals to breed successfully, we need to maintain the social bonds. So yes, it's something that's being considered for this species, that's always considered in the decisions on which individuals to move. So I think it's a starting point, and I think it's something that is being considered more frequently now in zoos.
Brilliant, that's good to hear, especially after the first talk of this session. What do you think the strengths and the limitations might be of this direct observational method for looking at social networks, social interactions, compared to this automated RFID tag method? And would that be kind of the same advantages and disadvantages in terms of research and perhaps more practical use within zoos themselves?
Yeah, there are lots of advantages and disadvantages. For us, it was very advantageous to have the RFID readers because it coincided with the pandemic. So Morgan was able to collect the data in person until she was sent home at the start of the pandemic. And then luckily, we just had these RFID readers ready. So she continued her PhD and finished on time. But obviously, there are the costs and benefits of all of these things. We know that they're not 100% reliable. We know that the RFID readers don't capture every single individual, for example. They're only in certain places. Animals may choose to avoid them. We certainly didn't see any avoidance behaviour, and we did habituate them to the readers. And obviously you get these massive data sets. So it takes a long time to analyse all the data that you do collect. So in-person behavioural observations are, I think, are always going to be preferable if you can. But again, it's having somebody available to do them, having somebody there 24 hours a day. I mean, the RFID readers captured nighttime behaviour as well, which hasn't been looked at before in this species. So there are lots and lots of different costs and benefits according to the species you're looking at.
And I guess following on from that, is there obviously, that's a large investment either in terms of time or money for most species and zoos. So from your experience, do you think there's a simple approach that might be taken from this that you could suggest to zoos, or other ways of encouraging them to engage in this kind of monitoring?
Well, I think the RFID readers can be quite cheap, actually, because if you think about it, everybody who's got a cat usually has a cat with a microchip in its neck. And a lot of us have these cat flaps that recognise cats going in and out, and they don't cost very much at all. So just modifying a cat flap could be used. So it doesn't have to be expensive. A lot of the animals already have the microchips implanted. So I don't think it's a big cost for zoos. I think it's more about having the expertise to analyse the data. And I think that's where we as scientists need to come up with easy ways for people to use the data and to analyse it and to use it to their advantage, because people don't have time to write R code and go through all this analysis. So I think that's where we can really help. We can develop apps, for example. We can develop code that people can use so that the zoos are are going to be more likely to use this kind of technology, and farms and all kinds of different situations as well.
Thank you. That sounds like another plug for open science and engaging with stakeholders as well there. So that's brilliant. Thank you so much, Christina. That's great.
Thank you.
So we're going to move on to our quick fire round of short talks now. So first up, just for anyone who missed this morning's session, questions will be taken at the end of all of the short talks together for all of our short talk speakers at the same time. But feel free to keep sending your questions in during the talks. So first of all, we have Janire Castellano Bueno from University of Newcastle.
Hello everyone, my name is Janire Castellano and today I'm going to present to you my PhD results on the cumulative experience of laboratory rhesus macaques, which I investigated using a multidisciplinary approach. Rhesus macaques are widely used animal models with long stays in research facilities where they may be repeatedly exposed to potential stressors. Ensuring the welfare of these animal models is critical both from an ethical and from a scientific point of view. Therefore, the aim of my project was to determine if there is a negative cumulative experience caused by husbandry or experimental procedures in laboratory rhesus macaques. For this project, we used the definition of cumulative experience as the net impact of all the events and effects that affect adversely, positively, and by way of amelioration, the welfare of the animal over its lifetime. In order to assess this cumulative experience, we need reliable indicators of long-term welfare. These indicators must be sensitive and specific to the valence of their effective state. For that, we reviewed the literature and found that the following were the best candidates: alopecia, the local amount of gray matter in the hippocampus, and inactive not alert behavior. We collected data from a total of 31 healthy rhesus macaques, both males and females, that were expected to stay in the facility for several years. The data was collected from 2014 up to 2022 every 6 months. For the data analysis, we investigated the changes in the welfare indicators over time using general linear mixed models and a within-subject approach. We then investigated the factors responsible for the change in the indicators using a model reduction approach. The factors included were involvement in experiments, ketamine sedation, non-steroidal anti-inflammatory drugs, antibiotic drugs, scrape surgeries, and AIDS, which were considered the best candidate factors as to have a long-term negative impact on the subjects. So, for the results, we found that the probability of being assessed to have alopecia increased significantly over the years, and that involvement in experiments was the best factor to explain that increase. For the behavioral indicator inactive not alert, we found that the frequency of the behavior increased significantly over the years. In this case, involvement in experiments was also the best factor to explain that increase. Finally, for the neuroimaging indicator, none of these factors was found to have a significant effect on the variability of the local amount of gray matter in the hippocampus over time. However, we suspect a lack of sensitivity due to a small sample size caused by COVID constraints might be contributing to this result, as the number of subjects for this indicator was lower. To conclude, using a multidisciplinary approach, we found evidence of negative cumulative experience in laboratory rhesus macaques that seems to be caused by involvement in experiments. Thank you everyone who has been involved in this project and made it possible. And thank you for listening. I'm happy to answer any questions.
Hi, thank you so much for having me here today. My name is Isabelle Mcdonald-Gilmartin. I'm a PhD candidate at the University of California, Davis, and I will be discussing one of the chapters of my dissertation focused on the consistency of abnormal repetitive behaviors in dairy cattle. Abnormal repetitive behaviors, or ARBs, are behaviors that are performed in a variety of species. And these behaviors indicate that something is wrong with the animal, the environment, or both. There are 2 ARBs that dairy cattle commonly perform. The first is tongue rolling, which is where the tongue is curled or moved in a circular way.
And the second is called non-nutritive oral manipulation, which is where the animal licks, bites, or sucks on objects in their environment that are not food or water. When it comes to the sampling or prevalence of these behaviors, less information is known, raising a potential question for the validity of future studies on these behaviors. Which brings me to some of my research objectives. First, we sought to determine the prevalence of ARB performance in adult dairy cattle at the UC Davis Dairy Facility, to measure the consistency of ARB performance across days, and finally to measure the relationship of tongue rolling and non-nutritive oral manipulation. Animals were housed in groups, and each group was observed using behavior sampling for 14 hours across 2 days. We had a total of 7 groups of adult dairy cattle with a total of 195 individuals ranging from 4 months to 6 years of age, and 37 Jerseys and 158 Holsteins. For our first objective, I will show you the average percent of animals in a group that performed each ARB on the y-axis and the type of ARB on the x-axis. We saw on average that 15% of animals in a group performed tongue rolling and 25% performed non-nutritive oral manipulation. To determine the consistency across days of sampling, we use Spearman rank correlations to compare the performance of each ARB on day 1 and day 2 of sampling. Each dot represents an observed group, and as you can see from our high R values, we saw a significant correlation between days, showing high consistency of these behaviors. We performed a similar method to compare the behaviors to one another, and saw that ARB performance was highly correlated to each other on both days as well. So overall, we saw that ARBs are prevalent in groups, that performance of ARBs is consistent across days, that tongue rolling is highly correlated to non-nutritive manipulation performance, and overall this suggests that we could reliably measure these behaviors on a single day of sampling. And with that, I am happy to take any questions. Thank you very much.
Hi, I'm Joseph. I'm a master's student at the University of British Columbia, and me and my colleagues were investigating whether the results of a judgment bias test are affected by pre-session discrimination and generalization training in dogs. Measuring how animals perceive the world is challenging but important, especially in a welfare context for animals in our care. Judgment bias tests enable researchers to determine individuals' optimism, which is an important component of how they perceive the world. Judgment bias tests rely on reinforcing animals for approaching one location, such as giving a reward when they go to the food bowl, and not reinforcing them for approaching another location. We then present them with a central ambiguous location where they've never been rewarded or unrewarded before. Their latency to approach this location is expected to represent how optimistic they are there's a reward in that location. Lower optimism is often expected to represent lower mood and, by extension, poorer welfare. But the judgment bias test is essentially a test of discrimination. So if you're more discriminative in the test, you appear to have greater optimism. So we aim to test if discrimination training could influence this optimism as perceived in a judgment bias test. Our method involved 2 judgment bias tests separated by a learning task. After completing the first test, dogs were randomly assigned to one of 2 treatment groups: discrimination treatment, where they were presented with 2 hands at the same time and only rewarded for touching one of the hands, or the control treatment, where they were presented with 1 hand in alternating sequence and they were rewarded with an equally distributed number of rewarded and unrewarded trials on either hand. We then did a second judgment bias test to see how their latency to the ambiguous location, their optimism, changed as a result of their learning treatment. We expected that the discrimination treatment animals would be perceived to have lower optimism than those in the control treatment. Overall, we did not find that training had an effect on judgment bias test performance. As you can see in the plot here, animals got about 10% faster in both treatment groups with no difference between them. This might be because the judgment bias test is robust as a measure of affective state with limited influence from recent learning experience. Our task might have also been too short or dissimilar to the testing procedures to have an effect on the test outcome, and we encourage future investigation of this topic. Thank you very much.
Thanks everyone. So I'd like to invite all of our short talk speakers to turn their cameras on. Brilliant, thanks very much. It's a really diverse and interesting set of talks there, and we have some questions for each of you. So first of all, to Janire, given your findings, what do you think we can do to improve the macaques' welfare? And do you think this evidence is strong enough to show that we shouldn't use them in experiments? Do you think there are things that we might do to buffer these negative experiences?
Yeah, thank you. That's a really great question. I think I could go for a while on this, but I'd say that from what we found is that involvement in experiment is indeed having a small but significant impact, but there are many factors that are integrated in that big factor that we tested. So really the next step would be to identify which specifically within that factor is having that impact. So for example, it would be really beneficial to test if longer breaks in between experiments could reduce the impact, and like compare it within compare the impact when we are also introducing some of the factors that we tested to have a positive impact as well in the long-term welfare. So yeah, I'm not sure if that's the answer you were looking for, but that's what I can say so far. Thank you.
Thanks so much. This question goes to Isabelle. Was it the same individuals that performed tongue rolling? And if the whole group was fed the same ration, would only some cows develop this behaviour, which I think has been associated with low roughage access? So it's about the individual differences in that behaviour.
Yeah, great question. So for the first question, we did see that most of the animals who perform tongue rolling are also the animals who perform the non-nutritive behaviors. We also saw that over 90% of all individuals performed the behavior, so we had pretty high prevalence at the individual level at all. In regards to the second question, if I understood it correctly, we did see that all the animals were fed the same total mixed ration with a mixing of breeds in the group, so they did get different amounts of access to that ration. But because they are being fed a limited amount of times per day, we do expect that the low amount of roughage that they're being fed does contribute to these high performances of the behaviors.
Thanks very much. Galia, we have a question about fish for you. And I guess this relates back to an earlier talk. So what do you think might be the barriers to people adopting this lidocaine administration for your stakeholders? And how do you think you might address some of those barriers?
So that's a really good question, because barriers are a big issue that we were constantly thinking about, and mainly it's integrating it into their methods, especially in the wild. It's really difficult for people to consider the safety aspects of also administering like local anesthetics on board, and a lot of people will steer away from it just because of that aspect in particular. But then one of the most important things that's also argued is time spent on deck, and that's why we particularly looked at that. So that's the handling time, and that's probably the biggest barrier for people. And there is quite a bit of research that handling time does affect fish negatively, and so we just have to make sure that we reduce that handling time as much as we possibly can, and also improve welfare while we do it. So if we can do both, we should consider doing both, in my opinion, but we'll see. Hopefully we can reduce it and show some results soon. Thanks.
Thanks so much. And a question for Joseph. Do you think it's possible that maybe human hands themselves are just rewarding?
Definitely possible, for sure. I think there's a lot of challenges with this type of experiment, and I think that could have been a limitation of our study for sure. I guess if I was to do it differently, I would increase the training time for the second task, and maybe even introduce a spatial discrimination task rather than one involving human interaction for sure, because we're limited by how different the treatments were. Definitely.
Thanks so much. Janire, final question, I think, before we move to a break. Do you, is it possible, do you think, to keep the team that work with the monkeys the same? Was that the case? And if not, could that help to lower the stress that monkeys experience?
Sorry, you mean like having the same?
Teams.
So I would say in many cases it was the same team that worked with the animals. There were some changes. We did not take that into account if there was a difference. But I would say overall, the handlers, the researchers, and technicians were pretty much the same. Yeah, for each individual. But it would be interesting to see if actually, you know, if they are habituated to the humans that they are around, and if that could have an impact. But yeah, I don't have an out there for that. Sorry.
Yeah, nice thing to investigate. Next PhD student. Thanks so much. I think that's all of our questions for this session. So we're going to move. If anyone has any more questions that they didn't quite get time to type in, then please put them on the Slack channel under the short talks section, #shorttalks. And we're going to move into the break now, and we'll be back at 16:20, so 4:20. So time to go and have a comfort break and grab a coffee. Thanks very much to all of our speakers in this session, and we'll see you again soon.
Thank you.